Hello, math learners! Our lesson for today is about conic sections. This is the Learning Pocket concept map, and we are going to focus only on the conic section and circle. We will have next time for the other types. The learning objectives are: you are going to define terms related to conics. Identify the types of conics. Express the standard form into general form and vice versa. Sketch the circle and solve problems involving equations and inequalities of circles. Let us have conic section. A conic section, or simply conic, is a curve obtained as the intersection of the surface of a cone with a plane. The types of conic sections are the circle, parabola, ellipse, and hyperbola. Conic sections can be generated by intersecting a cone with a plane. A cone has two identically shaped parts called napes. One nape is what most people mean by cone and has the shape of a party hat. This is the illustration. This one, we have the napes, a plane intersecting the cone, then a circle is formed. This plane intersecting the cone, then this is the ellipse, and this plane intersecting the cone, we have the parabola. And when the plane intersecting these two napes, then we have the hyperbola. Here are some sample images of conics in real life in the field of architecture. So this will serve as the illustration of the circle. This one is for parabola, and this structure is an example of a hyperbola, and this structure is an example of an ellipse. Let us have the key points. If we use a plane to cut the cone, the curve of intersection that the plane makes with the double right circular cone is called the conic section, or simply conic. Circle is formed when a plane perpendicular to cone axis. Ellipse is formed when a plane oblique to cone axis. Parabola is formed when a plane parallel to the side of cone. And hyperbola is formed when a plane cuts both halves of cone. Then let us have now the circle. A circle is a set of points in a plane, all of which are equidistant from a fixed point. The fixed point is called the center of the circle, and the distance from any point of the circle to the center is called the radius of the circle. Let us have now the standard form of the equation of a circle. So the standard form of an equation of a circle of radius r with center at the origin is x squared plus y squared is equal to r squared. You study the illustrations. This is the center represented by C. We have the segment or the radius represented by r, and the endpoint of the radius on the circle with coordinates represented by x and y. Let us have an example. We have the center at the origin, then draw a circle, and you have the radius equivalent to 3 units, and this point on the circle with coordinates 2 and 2.24. And do not forget to label the circle properly with its equation, center, the radius, and the corresponding point on the circle. Let us have examples on how to identify the center and the radius given the equation of the circle. For number 1, the given is x squared plus y squared is equal to 9. So the center is at the origin with coordinates 0, 0. And the radius is equivalent to 3 units. All you have to do is to take the square root of 9, because this portion is equivalent to r squared. So r squared, the square root of 9 is 3. Next, given x squared plus y squared is equal to 25. So again, if the form is like this is the standard form where the center is at the origin. So the coordinates of the center we have 0, 0. And the value of the radius is 5 units because the square root of 25 is 5. Another example, we have x squared plus y squared is equal to 10. So the center, we have the coordinate 0, 0. And then you can express the radius as the square root of 10. You don't have to change it to decimal. You can use the radical form. So r is equal to the square root of 10 units. For number 4, the given is 4x squared plus 4y squared is equal to 48. The center with coordinate 0, 0, still at the origin, and the radius is 2 times square root of 3 units. Let us have the solutions for number 4. Given 4x squared plus 4y squared is equal to 48, you have to simplify the equation by dividing each member of the equation by 4. So what we have, we can cancel 4 here, and 48 over 4 is equal to 12. So we have now x squared plus y squared is equal to 12. So the center is at the origin, so the coordinates we have 0, 0. And to solve for the radius, this part is the r squared. So r squared is equivalent to 12. All you have to do is to extract the square root of both sides. So we can cancel the square together with the symbol. Then simplify the radicand, then we have r is equal to the square root of 4 times 3. Then we can separate square root of 4 times square root of 3. The square root of 4 is 2, then copy square root of 3. That is why the value of the radius is 2 times the square root of 3. Next, let us have the standard form of an equation of a circle of radius r with center at hk, meaning the center is not at the origin, is equal to the square of x minus h plus the square of y minus k is equal to r squared. This is the illustration. The circle is located at the first quadrant. So this is now the center. We have the radius. And this is the standard form of the equation. So let us have an example. There you have the center, the radius, the point, and then the circle. So the name of the circle is the square of x minus 3 plus the square of y minus 3 is equal to 4. Let us have more examples. Given the equation, we have to identify the center and the radius. For number 1, the center with coordinates 3, and 3. For the radius, the square root of 4 is 2. So r is equal to 2 units. For number 2, the coordinates of the center, we have 2 and 5 because h is 2 and k is 5. And the square root of 16 is 4. So r is equal to 4 units. For number 3, the given is x squared plus the square of y plus 1 is equal to 5 squared. Since this is only x squared, so the value of h is 0. And here, this is positive 1. So originally, this is y minus negative 1. So the value of k is negative 1. That is why the coordinates of the center, we have 0, negative 1. And the value of r is 5 units. For number 4, the square of x plus 2 plus the square of y plus 6 is equal to 49 over 4. And the coordinates, we have negative 2 and negative 6. And for the radius, we have 7 over 2 units. Let us have the solutions for number 4. We have to find the value of h and k. So this is the given equation. So all we have to do is to simplify the equation by expressing it in the standard form of the equation of the circle where the center is hk. So x plus 2 and y plus 6 can be expressed into x minus negative 2, y minus negative 6. Therefore, h is equal to negative 2 and k is equal to negative 6. That is why the center is with coordinates negative 2 and negative 6. And to find for the value of the radius, we have r squared is equal to 49 over 4. So just simply extract the square root of both sides. Then what is left here is r. We cancel the symbol together with the square. And the square root of 49 is 7. The square root of 4 is 2. That is why r is equal to 7 over 2 units. Next, let us have the derivation of standard equation of the circle, which is the square of x minus h plus the square of y minus k is equal to r squared, with radius r and the center hk. Recall the distance formula. So the distance formula is p sub 1, p sub 2 is equal to the square root of the square of x minus 2 minus x sub 1 plus the square of y sub 2 minus y sub 1. Square both sides and simplify. So we have to square this and also the other side. Then here, we can cancel the square together with the symbol. So what is left is only this expression. Since P1 and P2 is equal to r, or the distance of the radius, and the center at point hk, then we have to substitute r squared to this expression, h to x sub 1 and k to y sub 1. So what we have, using this formula, we have to substitute r squared here, x sub 2 minus h here, and y sub 2 minus k here. Then, we have to remove the subscripts. We only have x minus h, then y minus k. Then, apply the symmetric property of equality. What we have is the square of x minus h plus the square of y minus k is equal to r squared. This is how to get the standard form of the equation of the circle where the center is not at the origin and represented by hk. For the center at the origin, we have to use the standard equation of the circle. And then substitute 0 to h, 0 to k, since the coordinates of the center are 0, 0, and then simplify. So it's like this. H is equivalent to 0 and k is equivalent to 0. X minus 0 is x. Y minus 0 is y. That is why we have x squared plus y squared is equal to r squared of the equation of the circle where the center is at the origin. Let us have now the general form of the equation of a circle. Algebra can be used to rearrange the standard equation of a circle to the general form of a circle. Let's expand it so that you can use more easily and see how it turns into the general form. The general form of the equation of a circle is x squared plus y squared plus dx plus ey plus f is equal to 0. You can recognize it because the two leading terms will always be x squared and y squared. Let us have an example. Express the given standard equation of a circle. The square of x minus 2 plus the square of y minus 3 is equal to 25 into general form. For the solutions, first we have to copy the standard form of the equation. This is the given. And then we have to expand the square of binomial. So the square of x minus 2 is equivalent to x squared minus 4x plus 4. The square of y minus 3 is equivalent to y squared minus 6y plus 9. Then copy 25. And then you can remove the grouping symbols. So just copy without the symbol. Then simplify. Write first x squared followed by y squared, then negative 4x, negative 6y, then 4 followed by 9 is equal to 25. And then you can transpose 25 to this side, equate to 0. Combine 4, 9, and negative 25, so what we have, negative 12. And the general form of the equation of the circle is x squared plus y squared minus 4x minus 6y minus 12 is equal to 0. So this is now the equivalent general form of the given standard form. And this is the illustration of the circle. Identifying the center with coordinates 2 and 3 because h is equivalent to 2 and k is 3. The radius is 5 since the square root of 25 is 5. And this point with coordinates 6, 6. Next example. Express the given general form of the equation of the circle x squared plus y squared minus 4x minus 6y minus 12 is equal to 0 into standard form. Meaning we have to change this general form in standard form. And this is the general form of the previous slide. So we have to go back to the original given standard form. First, copy the general form of the equation, and then you transpose negative 12. And then we have to complete the square. So first, we have to copy x squared together with negative 4x. Then you leave a space. Then copy y squared followed by negative 6y. Then you leave a space for the third term equals 12. And then the third term is 4. How will you get 4? All you have to do is to take half of 4, that is 2. and square 2, that is equivalent to 4. And here the third term is 9. Where did you get 9? That is coming from 6 divided by 2, or the half of 6 is 3. And take the square of 3, which is 9. That is why the third term is 9. Since you added 4 and 9 here, you also add 4 and 9 to the other side to balance the equation. And then, this is the first perfect square trinomial, x squared minus 4x plus 4. And the second perfect square trinomial is y squared minus 6y plus 9. Then you combine 12, 4, and 9. That is equivalent to 25. Then you have to factor each perfect square trinomial. You can factor into x minus 2 times the binomial x minus 2. And here we have the quantity y minus 3 times the quantity y minus 3 equals 25. Express into square of binomial. So this is equivalent to the square of x minus 2. And this 2 is equivalent to the square of y minus 3. Copy 25. So the standard form of the equation of the circle is the square of x minus 2 plus the square of y minus 3 is equal to 25, where the center is at 2, 3, and the radius is equivalent to 5 units. So from this general form, we're able to go back to the standard form. So this is the illustration. Again, we have the center 2, 3, radius 5, and the name of the equation with the point on the circle. Questions? If there is none, let's proceed. Let us have example number 2. Find the general equation of the circle whose center is with coordinates 2, 6, and whose radius is 3. Then you graph the circle. So we have the given h is equal to 2, k is equal to 6, and r is equal to 3. For the solutions, you copy the standard form of the equation. So this is the standard form where center is hk. And then substitute. H is 2, k is 6, and r is 3. Then all we have to do is to expand the square of binomial. So it's either you can use the FOIL method or the distributive method or the special product. So what we have is x squared minus 4x plus 4. And for the square of y minus 6 is equal to y squared minus 12y plus 36 is equal to 9. Then we have to remove the grouping symbol. Just copy and then simplify. So we have x squared followed by y squared, then negative 4x minus 12y plus 4 plus 36, and you transpose 9. So we have negative 9. Then combine the numbers and set the equation equal to 0. So what we have now is x squared plus y squared minus 4x minus 12y plus 31 equals to 0. So this is now the general form of the equation of the circle. And this is the graph. Center with coordinates 2, 6, the radius is 3, and this point with coordinates 5, 6. Do not forget the name of the circle. You have to write the equation. Example number 3. Change the equation x squared plus y squared plus 8x minus 6y equals 0 to standard form. And determine the center and the radius of the circle. And then you have to sketch the graph of the circle. So this is the given. For the solutions, you copy first the general form of the equation. And then you arrange and leave a space for the third term. Give a space for the third term and for the two additional constants. Then take the half of 8. And what is the half of 8? That is 4. Square it. And that is 16. Take the half of 6 and that is 3. Square it and that is 9. So what we have, x squared plus 8x plus 16 plus y squared minus 6y plus 9 equals to 0 plus 16 plus 9. So that is only 16 plus 9. Express the perfect square trinomial into the square of binomial, which is the square of x plus 4 plus the square of y minus 3. And 16 plus 9 is equal to 25. So the standard equation of the circle is the square of x plus 4 plus the square of y minus 3 is equal to 25. And the center of the circle is at negative 4, 3, and its radius is 5 units. This is the graph of the circle, center negative 4, 3, the radius is 5. And do not forget the equation. Next, example number 4. Determine the general equation of the circle whose center is 3, negative 1, and whose graph contains the point 7, negative 1, and sketch the graph of the circle. Given h is equal to 3, k is equal to negative 1, and the point with coordinates 7, negative 1. For the solutions, first, we have to use the distance formula to solve for the length of the radius since the equation is not given. So, recalling the distance formula, r is equal to the square root of the square of x minus h plus the square of y minus k. So, x is equal to 7, h is 3, y is negative 1, k is negative 1. Then 7 minus 3 is 4. Negative 1 plus 1 is 0. 4 squared is 16. 0 squared is 0. And the square root of 16 is 4. So, the value of the radius is 4 units. Next, we have to find the general equation. Using the standard form, the square of x minus h plus the square of y minus k is equal to r squared. We have to replace 3 to h, negative 1 to k, and 4 to r. Then we have to expand. We have x squared minus 6x plus 9. And the square of y plus 1 is y squared plus 2y plus 1 is equal to 16. X squared plus y squared minus 6x plus 2y plus 9 plus 1 minus 16. You just simply transpose 16 and equate to 0. What we have is x squared plus y squared minus 6x plus 2y minus 6. Because 9 plus 1 minus 16 is equal to negative 6. Equate to 0. So the general equation of the circle is x squared plus y squared minus 6x plus 2y minus 6 is equal to 0. And the graph of the circle is this one. Center 3, negative 1. This is the point on the circle, 7, negative 1. And label the circle with the name. The name can be the general form or the standard form. Next, let us have the circle tangent to a line. A tangent to a circle at point P with coordinates is a straight line that touches the circle at P. The tangent is perpendicular to the radius which joins the center of the circle to the point represented by P. The tangent is a straight line and the equation of the tangent will be of the form ax plus by is equal to c. The directed distance formula will be used in finding the value of the radius, whose formula is defined as d is equal to the absolute value of ax sub 1 plus by sub 1 minus c all over the square root of a squared plus b squared. Let us have an example. Find the standard and the general equation of the circle with center at 3, -5 and tangent to line y is equal to -1. Given center with coordinates 3, -5 and the tangent to the line y is equal to -1. For the solutions, first we have to solve for the radius. In ax plus by is equal to c, the given is only y is equal to -1. So we can express this into 0x plus y is equal to -1, where the value of a is 0. The value of b is 1. And the value of the constant is -1. For the center, we can use xy, which is equivalent to 3, -5. So x is 3 and y is -5. So using the formula, d is equal to the absolute value of ax sub 1 plus by sub 1 minus c all over the square root of a squared plus b squared, where d is equal to the radius r. All we have to do is to substitute the values. A is equal to 0, x is equal to 3, b is 1, y is -5, and c is -1. All over the square root of a, which is 0, then you square, b is 1, then you square. Then we have to simplify. 0 times 3 is 0. 1 times -5 is -5. Negative times -1 is +1. So the result is the absolute value of -4. The square of 0 is 0. The square of 1 is 1. So in the denominator, we have square root of 1. So what we have, the absolute value of -4 is +4. And the square root of 1 is 1. So 4 over 1 is only 4. So d is equal to 4 units. That is why the value of the radius is 4 units. For the standard form of the equation of the circle, this is the standard form. So all you have to do is to substitute. H is equal to 3, that is the x coordinate of the center. -5, that's the value of k because that's the y coordinate of the center. And 4 for r. So simplify. What we have is the square of x minus 3 plus the square of y plus 5 is equal to 16. So the standard form is the square of x minus 3 plus the square of y plus 5 is equal to 16. So this is the graph of the circle with center 3 negative 5, and this line is y is equal to negative 1. So this is the point of tangent C, which is 3, negative 1. Next, for the general form of the equation of the circle, just copy the standard form of the equation of the circle. Expand the square of x minus 3. That is, x times x is x squared. X times negative 3 is negative 3. Then times 2, negative 6x. The square of negative 3 is positive 9. Then y times y is y squared. Y times 5 is 5y. Times 2 is 10y. Plus the square of 5 is 25. Is equal to 16. And then rearrange. You copy x squared followed by y squared minus 6x plus 10y plus 9 plus 25 minus 16. And combine 9, 25, and negative 16. What we have is 18. So the general equation of the circle is x squared plus y squared minus 6x plus 10y plus 18 is equal to 0. Next, example number 2. Find the standard and the general equation of the circle with center at 6, 3 and tangent to the line 2x minus y plus 1 is equal to 0. This is the illustration. Center 6, 3, tangent to this line at point 2, 5 based on the illustration. So this is the given center, and 2x minus y plus 1 equals 0 is the tangent line. For the solutions, you solve for the radius, and we have to use the directed distance formula. So let us identify first the values of x and y. So x is 6 and y is 3. And for the line, identifying the values of a, b, and c. A is 2, b is negative 1, and c is negative 1. Then this is the formula. All you have to do is to substitute the values. So a is 2, x is 6, b is negative 1, y is 3, and c is negative 1. All over a, then you square. B is negative 1, then you square. And then simplify. 2 times 6 is 12. Negative 1 times 3 is 3. Negative times negative 1 is 1. Over 2 squared is 4. The square of negative 1 is 1. So that is 5. So 12 minus 3 plus 1 is 10. The absolute value of 10 over the square root of 5. Then we have to rationalize the denominator by multiplying square root of 5 over square root of 5. So this is now 10 times the square root of 5 over the square root of 25, because 5 times 5 is 25. And simplify. 10 times the square root of 5. Copy. As the numerator, the square root of 25 is 5. Then we're able, then reduce 10 and 5. So what we have is 2 square root of 5 units. Thus, R is equal to 2 times square root of 5 units. And 2 square root of 5 units is equivalent to 4.47 or 4.5. So approximately this is the radius equivalent to 2 square root of 5. And for the standard form of the equation of the circle, so you substitute 6 to h and 3 to k. R, 2 square root of 5. Then the square of 2 is 4. The square of square root of 5 is 5. So what we have The standard form is the square of x minus 6 plus the square of y minus 3 is equal to 20. For the general form of the equation of the circle, so using this standard form, all you have to do is to square x minus 6, that is equivalent to x squared minus 12x plus 36. The square of y minus 3 is y squared minus 6y plus 9 equals 20. And transpose 20, it becomes negative 20. And then rearrange what we have, x squared followed by y squared minus 12x minus 6y plus 36 plus 9 minus 20. Then simplify 36, 9, and negative 20, what we have is 25. So the general equation is x squared plus y squared minus 12x minus 6y plus 25 equals to 0. Next, let us have graphing inequalities of circles. In this lesson, we will determine if a given point lies inside, outside, or on the boundary of a circle using the equation of a circle in standard form with the use of inequality symbols. And these are the boundary rules. We use inequalities to determine these boundaries. Number 1, if the point forms a solution that is exactly equal to the given radius squared, then the point is on the circle. If the point forms a solution that is greater than the radius squared, then the point lies outside the circle. If the point forms a solution that is less than the radius squared, then the point lies inside the circle. If the inequality reads less than or greater than, then draw the circle using broken curve. If the inequality reads less than or equal to or greater than or equal to, then use a solid curve. Let us have an example first. Determine if a point lies inside, outside, or on the circle, whose equation is x squared plus y squared is equal to 16. Given the point with coordinates 0, 4. So for the solutions, all you have to do is to substitute 0 to x and 4 to y. So 0 squared plus 4 squared, that is now equivalent to 0 plus 16 is equal to 16. 16 is equal to 16 is a true statement. Therefore, the answer, the point with coordinates 0, 4 is on the circle. Another point given with coordinates 2, 5. For the solutions, we have x squared plus y squared is equal to 16. Substitute 2 to x and 5 to y. So we have 2 squared plus 5 squared is equal to 16. Then we have 4 plus 25 is equal to 16. 4 plus 25 is 29. And 29 is greater than 16. Therefore, the point with coordinates 2, 5 lies outside the circle. Another given, the point with coordinates negative 1 and 1. For the solutions, we have x squared plus y squared is equal to 16. And replace x by a negative 1, 1, 2, y. And simplify, we have 1 plus 1 is equal to 16. And 2 is not equal to 16 but less than 16. So the answer, this point lies inside the circle. So looking at this graph, This is point with coordinates -1 and 1. It's inside the circle. This point with coordinates 2, 5, it is found outside the circle. And this point with coordinates 4, 0 is on the circle. Do you have questions? If there is none, let's proceed. Let us have example number 1. Given the circle inequality x squared plus y squared is greater than or equal to 16, is the shading on the graph inside or outside the circle? Since the center is 0, 0 and radius is 4, then we have to test the values. Let us take point inside the circle, for example, with coordinates 2, 3. Copy the given equation and substitute the given values where x is 2 and y is 3. And simplify, we have 4 plus 9 is greater than or equal to 16. That is 13. And 13 is not greater than 16, so this is a false statement. Another, let's take a point outside the circle with coordinates -5 and 2. Using the equation x squared plus y squared is greater than or equal to 16, substitute -5 to x and 2 to y. Simplify, that is 25 plus 4 is greater than or equal to 16. And that is 29, which is greater than or equal to 16, and that is a true statement. This is now the illustration of the circle inequality x squared plus y squared is greater than or equal to 16, where you have the point with coordinates 2, 3 inside the circle and the point with coordinates -5, 2 outside the circle. And you can use other points outside the circle to test the given circle inequality. Therefore, the shaded region represents x squared plus y squared greater than or equal to 16 with a solid curve or a solid circumference, because all the points on the circle are also included. Next example. Given the circle inequality, the square of x plus 3 plus the square of y minus 2 is less than 36. Is the shading of the graph inside or outside the circle? Let us have the center -3 and 2. The radius is 36. And we have to test the values. Let's take a point that is inside the circle. So -2 and 4. So copy first the given and substitute -2 to x, 4 to y. Then simplify. -2 plus 3 is 1. 4 minus 2 is 2. And the result is 5. 5 is less than 36, which is true. Let us just take one point outside the circle. Say, for example, 4 and 5. So copy the inequality and substitute 4 to x, 5 to y. Simplify, we have 7 squared plus 3 squared is less than 36. And 58 is not less than 36. That is why this is false. Since the result 5 is less than 36, then we have to shade the inside part of the circle. And this will represent the circle inequality. And all the points outside are not included in the solution. Next, let us have the applications on the equations of circles. In this section, you will use the concept of circles to solve real-life problems, such as determining whether you are affected by an earthquake, able to receive radio waves, and many others. You will use circular models to illustrate real-life situations. Example number 1. The signals of a radio station can be received up to 10 miles away. Your house is 10 miles east and 8 miles north of the radio station. Can you receive the radio station signals? And explain. Let us recall, so this is the direction for the north, this is the west, south, and east. And for the solutions, you form the circle inequality, x squared plus y squared is less than or equal to 10 squared because it can be received up to 10 miles away. So this is the symbol to be used. Substitute 10 miles east, so this is the x part, and 8 for 8 miles north, so equivalent to y. And 10 squared is 100. And simplify, 10 squared is 100 plus 64 is less than or equal to 100. And 164 is less than or equal to 100, which is a false statement because 164 is greater than 100. Therefore, the answer is no. Since the signal can be received up to 10 miles away only, and you are not within the area. So for the illustration, if you live here, you are outside the circle. And the signal can be only until to the circumference of the circle and also within the shaded region. So you cannot receive anymore the signal. So the shaded region represents the area coverage of the signal. Next. A rabbit will move not more than 10 miles away from its hole. At that time, you are taking a walk about 5 miles east and 7 miles south of the rabbit hole. Is there any possibility of you meeting the rabbit? For the solutions, you form the inequality x squared plus y squared is less than 10 squared because the rabbit will move not more than 10 miles. So it's less than 10 squared. Since you walk about 5 miles east, so that is the x value. 7 miles south, that is the y value. It's less than 100. 5 squared is 25, 7 squared is 49, is less than 100. And 74 is less than 100. And this is true. Therefore, the answer is yes. There is a possibility since you are within the area of the rabbit. So this is the illustration. If this is the hole and you are just simply here and the rabbit will just move around here, so there is a possibility that you will meet the rabbit. The shaded region represents the area of movements of the rabbit. And it's a broken curve because the symbol is less than. Next example. The equation of the merry-go-round is x squared plus y squared is equal to 25 Find its center and radius. Determine the area of the circular field where the ride is located. For the solutions, first, we have x squared plus y squared is equal to 5 squared. So, the center is at the origin, 0, 0, and the radius is 5 meters. And to find the area of the circular field, this is the formula for the area of the circle, which is equivalent to A is equal to pi r squared. And substitute 5 to r. So we have pi times 25. And the area is 25 pi or 78.54 meters squared. This is the area of the circular field. So this is the illustration. So if this is the merry-go-round, you are asked for the area where the merry-go-round is located. Next example. Let's say you are a gardener and you have just planted a lot of flowers that you want to water. The flower bed is 15 feet wide and 15 feet long. You are using a circular sprinkler system, and the water reaches 6 feet out from the center. The sprinkler is at coordinate 6, 7. What would be the equation of the circular movement of the water? What is the area being watered by the sprinkler? What percentage of the garden that is being watered? For the solutions, coordinates of the center 6, 7, the radius is 6 feet. The equation of the circle is the square of x minus 6 plus the square of y minus 7 is equal to 6 squared, or the square of x minus 6 plus the square of y minus 7 is equal to 36. So the center of the circle is at coordinates 6, 7. The water reaches 6 feet out from the sprinklers. So the radius is 6 feet. Next solution. Let us have A to represent the area of the sprinkler. And the formula is pi r squared. So pi times 6 squared, it's 36 pi, or equivalent to 113.10 feet squared. The formula for the area of the circle again is A is equal to pi r squared. And the area that is watered by the sprinkler can be labeled by area sub the sprinkler. So we can use the formula A sub sprinkler is equal to pi r squared. And for letter C, percentage watered is equal to the area of the sprinkler over the area of the flower bed times 100%. The area of the sprinkler is 36 pi over 15 squared, as the area of the flower bed, that is 15 by 15, times 100%, and you may change 36 pi into 113.10 over the square of 15 is 225 times 100%. So the percentage watered is 50.27%. Because we have to assume that the area that is watered is completely inside the garden. The percentage of the garden that is watered can be found by dividing the area of the water by the total area of the garden and then multiply by 100%. Do you have questions? If there is none, see you next time. Bye!